the two possible arrangements for a bipolar montage. The other popular and probably more popular montage is the referential montage. So in a referential montage, you have a reference electrode. And the reason you have to have that is because, remember, all voltage measurements are differential by definition. And so we have to have a reference somewhere. So the actual outputs that you get from a referential arrangement is the difference between the measurement electrode and the reference electrode. So this sort of begs the question, what are some common references? So here is a common one. This is the CZ referential electrode. CZ is the electrode right in the middle of the head. And so essentially what you do when you choose CZ as a reference is you have the difference of your channel locations and the CZ electrode. So one choice obviously is the central electrode CZ to be your reference. Another choice is to have the two earlobes be a reference. This is referred to as A1 and A2, with one being on the left and the other being on the right. And so here all of the electrodes on the left side would be referenced to the left earlobe. All of the electrodes on the right side would be referenced to the right earlobe. Another option is, and this is kind of common on research, in research systems, and in fact NeuroScan, the new NeuroScan systems use this, and that is an average reference. So what happens here is the software itself takes an average of all of the electrodes. So you have all your signals coming in, and you would take an average of all of those signals, and then that is defined as the reference. So then each individual electrode would be that electrode signal minus the average reference. Another option is Laplacian reference. This is kind of an average is maybe not the best word to use here, because really it's kind of a weighted average of the nearest neighbors to a given electrode. The reason you can't quite call it an average is if you're at one of the electrodes on the edge of the arrangement, then you don't have quite the same nearest neighbor set as if you're in the middle of a head. So it's kind of a weighted / modified average. But nevertheless, it would be the electrodes that are closest to the measuring electrode. So sometimes you will acquire data in one way and then discover later that really, for whatever kind of analysis you're doing, you wish you had acquired data in another way. If you're in a clinical environment, you're often out of luck, because most clinical systems require that the technician selects the montage. This does not mean that you physically rearrange the probes. It means before you record the data, you tell the system what your montage will be, and then it records it under that particular arrangement. If you're using a referential system, it may be possible to remontage in MATLAB, because if you think about it, if you have probe 1 minus A1 and probe 2 minus A1, if within a spreadsheet or a matrix you were to do those two signals subtracted, the A1s would cancel and you get probe 1 minus probe 2. So you could go from referential to bipolar, but it would be very hard to go back the other direction, because you don't have, if you've recorded bipolar, you can't really invent a reference. Research systems, on the other hand, usually provide the option to remontage after the fact using software, because the data are not recorded as montage data. They're recorded as just channel data, and just the way that the data come in, and then the actual referencing is done after the fact, because these systems also have a ground or a virtual ground. So So research systems, you often do have the opportunity after the fact to remontage using the software, and that's true of the EEGI system. So there's been some research on does the montage make a difference? And so does it make a difference in what? Well, what are we using the EEG for? If you're using the EEG to localize something like a seizure or seizure activity, then yes, the montage can make a difference, and the bipolar is often the best one because, or the transverse, because then things show up in a more localized way. Does it make a difference in coherence? Yes. If you're doing coherence calculations and you do not have a reference electrode like an earlobe or a CZ, then you can often get common mode noise or common mode signal on multiple channels. And when you do connectivity or coherence measures, that shows up as a false coherence or a false correlation. So the choice of reference can definitely influence coupled channel type calculations. I realize that we have not talked about coherence and connectivity and a lot of these things at this point. We will discuss those in one of the lectures associated with this class. Just giving you a heads up that there have been some publications and some studies done on does the montage make a difference when you're analyzing EEG? And the answer is yes, it does. So you may, if you're doing a particular study and you know what kind of model you want to do after the fact, it may be worth thinking about how the electrode arrangement is set up before you begin to acquire that data.